Whenever you do a question on blood grouping, the very important thing you need to remember is this is an example of multiple alleles. So normally we've had two alleles for a trait, one allele for purple color, one allele for white color, one allele for gray fur, one allele for black fur, for example. Now we have three different alleles controlling blood groups. IA and IB, you must attach them to a capital letter I with a superscript A and a capital letter I with a superscript B. These are both co-dominant, meaning both alleles are equally dominant. So when they are both in the genotype, they will both be expressed equally in the phenotype. But the third allele is just a small I with no superscript. You don't put a superscript up there. And that small I is showing you that this allele is recessive to IA and IB. So both of these two alleles are completely dominant over this one. This table is your best friend when it comes to blood grouping. It shows you the four phenotypes, which are the blood types, A, B, AB, and O. And it shows you the different genotype options. Someone can either be homozygous for A and homozygous for B, where those two alleles are both dominant alleles, or someone can be heterozygous for A and heterozygous for B, where they have a dominant allele and a recessive one. But physically, phenotypically, they are still type A. And this guy, phenotypically, he's still type B, because that allele is completely dominant over that one. For type AB, you cannot be homozygous. It's physically impossible because AB is different alleles, so you have to be heterozygous. And for type O, you have to be homozygous recessive, because as soon as you have one of the dominant alleles, you will no longer be type O, because that dominant allele will mask the recessive ones. So O is the recessive blood type. Let's look at one example. So Anne is blood group O and has a daughter who is blood group B. There are two possible fathers. Frank is blood group B and Graham is blood group AB. Is it possible that Graham is the father? Show how you worked out your answer. So all you need to do is have this table in your mind. If Anne is blood group O, that is her genotype, and we need to check Graham's genotype because that's what the question is asking, and his genotype will be IAIB. So you just do your genetic cross. You have Anne being type O crossed with Graham type AB, Anne's genotype small I crossed with Graham's genotype IAIB. Then you have the gametes. Anne can only give a small I to her offspring. So she can only give that recessive allele, and Graham can either give a dominant IA or a dominant IB. Then when you show fertilization in your Punnett square, you put your Punnett square over here, and you put Graham's gametes at the top and Anne's gametes on the side, and you do your cross to show the possible genotypes of the offspring. So the genotypes of the offspring are going to be IA with a small I or IB with a small I. Those are the two options. So the phenotypes of the offspring are either going to be type A or type B. So therefore, are we proving that it is possible that Graham is the father? Absolutely, because the daughter is type B. So that daughter could be one of those two children. So when you're doing a genetic cross for blood types, it's just a question of proving the possibility of a person being the parent, in this case, the father. So remember, it's only possible that Graham is the father. Frank could also actually be the father because he could have been this genotype or that genotype, but either way, he could have given an IB to the daughter. So blood types only show that someone possibly is the father or mother, or definitely is not, because many people in the world have the blood type AB, many men, to be specific for this question. So if Graham was type A, for example, if this was his genotype, it is impossible to have the daughter who is type B if the wife is type O, because the wife will give a small I and Graham would only be able to give an I big A. So the daughter would end up with that genotype, which would make her type A, not type B. So it's important that we are only proving that Graham possibly is the father. And you would end your answer saying, therefore, Graham possibly is the father because his daughter could be type B.